Hey kiddos, so I have some fraction big ideas, or basically here we're going to be doing some review. I just wanted to send out something about reviewing for you guys. So, fraction parts are equal shares of a whole. This could be part of a number line, an object, or a set of objects. Fractional parts are equal shares of a whole, so that could be part of a number line, an object, or a set of objects. In this representation, the whole would be this rectangular shape, right kiddos? Now, fractions are equal shares of a whole. This could be part of a number line, an object, or a set of objects. This was the whole, and they have split it into 1, 2, 3 parts, which means our denominator would be a 3, right? And it would be 3 for sure. We haven't shaded anything in. If we had shaded 1 in, it would be 1/3, but we don't know what our numerator is yet. We just know this was split into 3 different sections, so the denominator would be 3. Each of these is worth 1/3, right kiddos? Because we split the whole into 3 parts. 1, 2, 3. So this is 1/3, this is another third, and this is another third, right? Now here we have the number line, and if we're going to split that, we would split it into sections also. Here's the first one, the second, and the third. So 1/3, 2/3, well, another third, and another third, right? Each of those is worth 1/3. If we were going to mark it on the dash mark here, this would be 1/3, 2/3, and this would be like 3/3 or also 1, right? Just like that, 1/3, 2/3, or 3/3, which is equal to 1, or the whole. Now we have a representation using a set of objects. Here's one set, here's the second set, and here's the third set. This whole grouping would be considered the whole. There's 1/3, there's another third, and there's another third. Fractions have special names that tell us how many parts of that size are needed to make the whole. Thirds mean 3 parts to make a whole. 1, 2, 3. That makes the whole, right? 1/3 plus 1/3 plus 1/3 equals 3/3, or the whole. Fractions have special names that tell us how many parts of that size are needed to make the whole. Thirds need 3 parts to make a whole. This one had more parts, right? 1, 2, 3, 4, 5, 6. So 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. So the whole would be 6/6. Here is another representation. 1, 2, 3, 4. So there's 4 groups, which means you need to have 4. It would be 4/4 would be the whole, right kiddos? 1, 2, 3, 4. 4/4 is the whole. Each of these is worth 1/4. 1/4, another fourth, another fourth, and another fourth. The bottom number of a fraction tells how many parts the whole has been split up into. So the bottom number here is the 3. That means the whole will be split up into 3 parts. So here is your whole section. You would split this into 3 parts. 1, and you'd have 2 lines. 1, 2, 3, right? 1/3, 1/3, 1/3. Now this one is 2/4. So we're going to split it into fourths. This whole would be split into 4 sections. 1, 2, 3, and 4, right? 1, 2, 3, and 4. Now if we're only going to count, if we're at our numerator says we are going to count 2 of those, right? So there they are. 1/4 and 1/4 is 2/4. The more fraction parts are used to make the whole, the smaller the part is. For example, eighths are smaller than fifths. So the more fraction parts that you need to make the whole means that they are the smaller part. And let's look at an example of that. Here's how fifths will look. 1, 2, 3, 4, 5. Eighths will have to be smaller, right? To be split this whole into 8 parts. See? 1, 2, 3, 4, 5, 6, 7, 8. Those are much smaller than these are, aren't they? Two equivalent fractions are two ways of describing the same amount by using different sized fractions. Let's look at an example. So they're going to have fourths here. They broke it into 4. 1, 2, 3, 4. The next one is eighths. So those are going to be smaller, right? 1, 2, 3, 4, 5, 6, 7, 8. See, the eighths are smaller than the fourths, aren't they, kiddos? But, let's look at that. Do those look equal to each other? 1/4 and 2/8, because they are equal to each other, right? 1/4 and 2/8. If we made, they are the equivalent of each other. 1/4 equals 2/8. All right, just a couple things to remember. Fractional parts are equal shares of a whole. This could be part of a number line, an object, or a set of objects. Fractions have special names that tell us how many parts of that size are needed to make the whole. Thirds need 3 parts to make a whole. And like quarters would need 4 parts, halves would need 2 parts, fifths would need 5, sixths would need 6, eighths would need 8. It just keeps going on like that, kiddos. The denominator of a fraction tells how many parts the whole has been split up into. The more fraction parts that are used to make the whole, the smaller the part. An example would be eighths are smaller than fifths, right? Because you had to split the whole 8 times, rather than with fifths you'd only need to split it 5. So each of those sections would be bigger. Just think of that like if you wanted a piece of pizza and someone was going to split it into eighths or fifths and you were hungry, you're going to want them to split it into fifths because your pizza will be bigger. Two equivalent fractions are two ways of describing the same amount but using different sized fractions. All right, kiddos, so that was just a brief review of those things, and I just wanted to share it with you. I really hope that fractions are going okay with you and that things are going really well. And I really miss you guys.